All right, so as we continue on through this way, you'll have to demonstrate that you know exactly what I need you to know through an exit ticket. Well, for that, the best thing you can do is to do practice. Practice. So we've already done an investigation, and then you're going through these videos, which are almost done. Maybe not almost done, but then you're going to be doing practice. And really the best way for you to prepare for this class is to practice. So here are some examples before you get down to practicing. Students are investigating the motion of a car that starts from rest and accelerates forward, then brakes to rest. Students separate themselves so they stand 10 meters apart and each holds a stopwatch. All of the students start their stopwatches on a signal. Each student stops their watch when the car passes by. The data table shows the data taken. First thing I want to point out is these two words here. When you see these words rest, that means you're not moving anywhere. Whatever object you're thinking about, that object is going exactly 0 meters per second. It's starting from rest, so the initial or the starting velocity is 0 meters per second. Then it brakes to rest, so that means at the very end of the situation, or the final velocity, is going to be 0. When does the car begin slowing down? So, looking at the data table, we have this distance that has been traveled, and then we have this time that has elapsed. So, 0.23 seconds have elapsed, 3.06. We've got to look at the difference between the adjacent times to get that elapsed time. What's the average speed of the car for the entire travel? Remember, speed is distance over time elapsed. Okay, so we started out with 0.23 seconds on the clock, and then we ended with 0.23 seconds on the clock. So the elapsed time, the total elapsed time, is 10 seconds. So to get the average speed, total distance divided by total elapsed time. 100 divided by 10 seconds. So we get 10 for the average speed. What about the instantaneous speed at 5 seconds? We're going to look at the data points, one before 5 seconds and one after 5 seconds. The small distance traveled is 10 meters, and the small time elapsed is 0.9. Dividing 10 by 0.9 is going to give us 11.1. What is the fastest speed the car attained? That's going to happen when the time difference is the shortest, right? Because all of our distances are equally spaced out. So the shorter time in that denominator is going to give us a larger answer. Small distance, the 10 gives us 19.52. All right, for this one, I want you to pause and I want you to answer that. Now that you're back, here you go. Total distance of 120. Let's do the same thing. If you're asked for the magnitude of displacement, you would just answer 60 meters. And that's because we are 60 meters to the right of the initial position. Straight line from the final to the initial is your displacement. Here you go, pause it again. Get your average speed, not velocity, speed. Ready? Total distance we already found was 120 meters. The total time spent is 20 seconds, so that gives us 6 meters per second. All right, go ahead and pause it here and see if you can figure out the average velocity. And here we go. We know the net displacement is 60 to the right. The total time is 20 seconds. Dividing the net displacement by the total time is going to give us 6. That's the magnitude of average velocity. It's not the same as your average speed. Remember, magnitude is just how much or how big. The direction of the average velocity is to the right, so it's going to be a positive. The same direction as the net displacement. And that's it for this. Next will be some practice.